Hello, class. This is the second recording on chapter 3.6. I'm just going to do two examples in this video that are going to be slightly more complicated. I call this kind of the chain rule onion. This is like the idea where you just have several layers of chain rule, or you may have chain rule kind of integrated with another technique. So you could consider the previous end example where we talked about quotient rule as similar to this, because it's a little more complicated than just the basic quotient rule or the basic chain rule. So we're going to look at this function, and it is sine squared of quantity 2x cubed minus x. And so there is two layers to this problem. There's a squared layer, and then there's the sine function, and then there's the inside of the sine function. So whereas a normal chain rule has an outside and an inside, this has three layers. It has an outside, a middle, and an inside. Okay, and so we got to be a little bit careful when we do chain rule here. So let me rewrite this function, and you need to make sure that you do chain rule from the outside in. Okay, we want to start from the most outside in. In this case, the most outside part of this is the squared, and it's a little more obvious if you rewrite your sine squared like this, exactly what's going on. And so written like this, I think it's more obvious that you do the squared first, then the sine, then the 2x cubed minus x. We're going to work our way from the outside in. So to remind everybody, when we're taking the derivative of a composition of functions like this, okay, we take the derivative of the outside function, that is the f function, and we evaluate that at the inside unchanged. So one more time, I'll note that this inside g of x has not changed at all from the original to the derivative, but we do need to change it when we multiply by this adjustment term, where we scale the derivative by the rate of change of that inside function, g prime of x. Okay, so here, let's do f prime first, and then we'll write out what g prime is going to look like. So the most outside is this 2. So when I do f prime of x, I'm going to bring the 2 down, and then I have sine 2x cubed minus x. Again, I have not changed anything on the inside of the sine yet, or at all. And then I have 2 minus 1, right, for my power rule. I got to take the derivative, though, of the entire outside. So from the perspective of the squared, all of this is on the inside. And so when we take the derivative of the inside, the first chain rule, we'll take the derivative of the entire inside. That is to say, we'll take the derivative of the entire sine function. And what you'll notice is that this sine function that we get as a result of this process is itself another chain rule. Okay, so there's two layers to the chain rule, and we have to do it at every layer. If there were 5 layers, we would do chain rule 4 times. This has 3 layers, we do it twice. So you always have to do chain rule one less time than the number of functions you have. And so here we have the squared, the sine, and this polynomial. We'll do chain rule twice because we have 3 functions. Okay. So let's talk about how we do this sine rule, or this chain rule, excuse me, for sine. And so look at this one. This one now has an inside that looks like 2x cubed minus x. And so let's bring this down. We have 2 times sine of 2x cubed minus x. And 2 minus 1 is really 1. So we generally don't write that. You could write it right here if you really wanted to, but we'll just leave that like that. And then we'll multiply by the derivative. Well, we're going to do our chain rule again. Same rule, except our f is now referring to a different function. Our f is now sine instead of being the squared function over here. So from sine, we know its derivative is going to be cosine, right? So the derivative with respect to x of sine of x is cos of x. This is one of the rules that I expect y'all to know by next week. And so when you multiply this in, we're going to get cosine, and the inside is now that 2x cubed minus x, and so I'll write that same thing right here, 2x cubed minus x. Okay, that's good, but we have to do chain rule. So I need to multiply by an adjustment factor for the inside, and that is d dx of whatever the inside is, 2x cubed minus x. Okay, well, let's go ahead and bring this all together. This is going to give us, we're going to bring the 3 down. 3 times 2 is 6, and this is going to become 3 minus 1 is 2, so 6x squared. The derivative of x is 1, so this is really 6x squared minus 1, and we'll go ahead and move that up front. Okay, I prefer to put my polynomials in front and then the sine functions after, and that just decreases the likelihood that I somehow bring the polynomial into the trig functions. So 2 times sine of 2x cubed minus, oh, no, I'm writing the sign first. I want to write the polynomial first. So this is 2 times 6x squared minus 1 times the sine 2x cubed minus x times the cosine of 2x cubed minus x. And we could distribute the 2 to make this 12x squared minus 2, but it's not going to really make too much difference, so we'll just go ahead and leave it like this. That's a perfectly fine final answer. If you wanted to go further, you could notice that 2 sine x cos x is equal to cos of 2x, and, oh, sorry, sine of 2x. I apologize for the background noise. It's trash day over here, so you may hear a trash truck in the background. 2 sine x cos x is equal to sine of 2x. Using this identity, since we have sine, cos, and a 2, we could actually take this one step further. And so we could write this as sine of 4x cubed minus 2x, where we're just doubling 2x cubed minus x. If you're curious where that's coming from, that is coming from distributing the 2 like this. Okay? So that's a possible final answer, but I'm not too worried about that in terms of the final answer. I would be perfectly fine with this. If you're really comfortable with the trig, though, it is kind of a nice way of compacting the final answer. Like, in my opinion, that is a nicer final answer, but it's not ultimately a large deal. I'm not going to take any credit if you don't notice this particular thing. And if I really want you guys to use an identity like this, I would let you know in the problem itself. I'm going to do one more illustration. And so this isn't written in your notes. You guys will have to add this yourselves, but we're going to do one more problem. And I just want to basically show you guys how another way this can be done. And so there's actually 2 chain rules here. This guy right here, there's 2 layers to it. It's got the tan and the x squared on the inside, so that's a chain rule. And this has x squared plus 2 and a third power. That's another chain rule. But there is another complication. These are being multiplied together, so the whole thing is going to be a product rule, okay? So keeping count of this, this has 2 chain rules and 1 product rule in it, and that's going to be relatively normal as we go forward. As we develop your guys' derivative skills, we're going to stop applying things in very simple ways, and we're going to start layering these rules together. So you can expect to see chain rules inside of product rules inside of chain rules, all those kinds of combinations, okay? So let's do this one, though. We have a product rule. I will remind everybody what the product rule is, though at this point you really should know the product rule. If you do not, you need to return to earlier chapters. I believe we did product rule in 3.3 or 3.4, and you should go back and practice that, okay, with some of the simpler functions. Because the further we go, the more I assume that you guys know how to do this. But the product rule says, hey, you take the derivative of the first function times the second, plus the first function times the derivative of the second. Okay, and then you add those 2 up. That's the product rule. And so we'll apply that here. My f of x is x squared plus 2 cubed. My g of x is tan of x squared. I'm going to go ahead and do this work. I'm going to split it out because each of these derivatives is a chain rule. And so it should make my life a little bit easier if I do these chain rules separately rather than trying to do them all in one line. Okay, so I want to take the derivative of x squared plus 2 cubed. How do I do that? Well, I bring the 3 down like normal for a power rule, subtract 1 from it, 3 minus 1 is 2, and then I multiply by the derivative of the inside. Okay, what is the derivative of x squared plus 2? Well, that's 2x. Our g prime, similarly, is the derivative with respect to x of tan of x squared. I like to use brackets here. I know what the derivative of tangent is, so we'll do our chain rule again. We'll take the derivative of the outside function. Derivative of tangent is secant squared. This is another one of those derivative rules that y'all need to know. I'll write it up here to remind everybody. Take the derivative of tan. That is secant squared. Okay. And so we get secant squared of not x, but x squared, because again, when we do chain rule, we keep the inside the same. We did that here, and we did that here as well. Secant squared, x squared, and then I got to multiply by the derivative of that. Well, derivative of x squared. I'm not going to write it all out. You guys hopefully are getting the point by this point. And so when you take the derivative of x squared, you get this adjustment factor 2x. Okay. And so we could clean this up a little bit. Let's see. Let me just write the final answer. We've got enough there, I think, that we can jump to the final answer. So y prime remember we do this kind of cross multiplication. So you're going to take this guy, f prime, and you're going to multiply it by g. And you're going to take this guy, g prime, and you're going to multiply that by f. Okay, so let's do it. I'm going to put the polynomials first. X squared plus 2 cubed times 2x secant squared of x squared plus 2x times 3. We might as well combine like terms here. That's 6x. X squared plus 2 squared. And I'm multiplying that by tan x squared. Okay. Could we make this look a little nicer? So myself, I don't particularly like having this 2x between, so I would probably move that up front and then move this further over. Oops. See if I can try that again and not screw it up this time. I would personally rearrange this and put the 2x there, but it's really more of a preference thing. There's not much that can be done to simplify this. Like you can't really combine tan and secant squared. They have different coefficients to begin with. This is squared and that's cubed, so we can only just live with what it looks like. It is what it is. Sometimes the algebra doesn't give us the cleanest looking answer, okay? That's totally fine. And in fact, many real world problems are far worse just because the real world doesn't doesn't comply with our desire for clean algebra, right? That'll take care of my final examples for chain rule. There's a lot of homework questions on chain rule. When we do 3.7, we'll be doing more. So if you're still feeling a little unconfident on chain rule, then watch the videos on 3.7, which is the exponential and log derivatives. And we'll see you there, okay?